This is part C of chapter 11, solve radical equations. Now a radical equation is more than just an equation with a radical in it. It's important that there's a variable in the radicand. Otherwise, if there's not a variable in the radicand, it's not necessarily a radical equation, it just happens to have a square root in it or a cube root in it. Extraneous is kind of like the word extra with a bunch of extraneous letters at the end. It's a solution obtained by squaring both sides of a radical equation that is not a solution of the original equation. Now, that's kind of strange, but what we'll learn today is a new equation solving technique, squaring both sides. And what happens is sometimes when we do that, we create a solution that wasn't there at the beginning. So we have to guard against that because it's not really a solution of the equation. To use that equation solving strategy, we need to point out that if two expressions are equal, then their squares are equal. So if a equals b, then a squared equals b squared. Now that's not a two-way street. 4 squared is 16, negative 4 squared is 16, but 4 doesn't equal negative 4. And that's really the idea, sort of the idea behind extraneous solutions. Sometimes when we go back that way, we can have things whose squares are equal, but the original numbers aren't equal. We'll take a look at some examples and see how this works. So, number 1, we have 3 times the square root of x plus 1 minus 15 equals negative 6. Kind of like when we did absolute value equations, there's a big difference between inside and outside. Things that are outside, just like if we had 3 times b minus 15 equals negative 6, the first thing we do is add 15 to both sides. Well, we'll do that here too. We'll add 15 to both sides. And get 3 times the square root of x plus 1 equals 9. Then we'll divide both sides by 3. We'll get the radical expression, the square root of x plus 1, all by itself. Now we have to be really careful. We will not be subtracting 1 from both sides, because the plus 1 is underneath the radical. So now we will square both sides. The purpose of squaring both sides is to cancel out the square root. Now it might look like this side's really complicated. Well, not really. The square root of x plus 1 all squared is x plus 1. 3 squared is 9. And we get x equals 8. Now, we do need to check that. Not just to see if we did our work right, but also in case we get an extraneous solution. So let's see, if we put 8 here, 8 plus 1 is 9. Square root of 9 is 3. 3 times 3 is 9. Minus 15, negative 6. Number 2, the minus 2 is outside the equation, or outside the radical, so we'll add 2 right away. And we'll get the square root of 4x minus 19 equals 7. Now, we will be adding 19 and dividing by 4, but not yet. The radical is by itself on one side of the equal sign, so it's time to square both sides. Because if two things are equal, their squares are equal. The square root of 4x minus 19 squared is 4x minus 19. 7 squared is 49. Now we add 19 to both sides and get 4x equals 68. Divide by 4 and get x equals 17. We'll check that as well. 4 times 17 is 68, minus 19 is 49, square root of 49 is 7, minus 2 is 5. 3. Now, this is a little different situation. We have radicals on both sides, but they're both the only thing on both sides. So I'll just rewrite that as is for now. We will square both sides right away. The square root of 3x minus 3 squared is 3x minus 3. The square root of 2x plus 8 squared, 2x plus 8. Now you might recall that with these equations, we have 4 possible correct first steps. In this case, one of those 4 steps gets us there faster. So we'll choose that one. Fewer steps if we subtract 2x from both sides to get x minus 3 equals 8. Add 3. X equals 11. We'll check that. 3 times 11 is 33, minus 3 is 30, so that side's the square root of 30. 2 times 11 is 22, plus 8 is 30. The square root of 30 equals the square root of 30. Number 4 is also a situation where, since the radical is by itself on one side of the equal sign, we can square both sides. X squared, square root and squared are inverses, inverse operations, so we get 2x plus 15. Now we have a quadratic equation. Spent a lot of time solving quadratics in different ways in chapters 9 and 10. One thing to remember is that we always want it equal to 0. And it's almost always easier if our leading coefficient is positive. So it might seem easier to move one term instead of 2 terms. However, to get this first term, to keep this one positive, let's subtract 2x and 15 from both sides in one step. And remember, none of these are like terms. Boy, wouldn't it be neat if the quadratic formula showed up here? Well, I know it's an option. We have a quadratic equation. We could certainly use a quadratic formula. Maybe it factors. So we'll take a minute to see. If it doesn't factor, we'll just use a quadratic formula. Well, it would have to be x times x. Multiply to make a negative means the signs are mixed. Multiply to make a negative 15, combine to make a negative 2, positive 3 and a negative 5. Now, the zero product property, all kinds of great review here. If this times that equals 0, either this equals 0 or that equals 0. If x plus 3 equals 0, x equals negative 3. If x minus 5 equals 0, x equals 5. So x equals negative 3 or x equals 5. You're right, we need to do the check. So we'll start with the 5. Does 5 really equal the square root of 2 times 5 is 10 plus 15? 10 plus 15 is 25, square root of 25 is 5. Yes. Does negative 3 really equal the square root of negative 6 plus 15? Does negative 3 equal the square root of 9? No. So the negative 3 is an extraneous solution. Now you can write that. You can write negative 3 doesn't check. And that can happen because negative 3 squared is 9, but negative 3 is not the square root of 9. So only the x equals 5 is a true solution